Good morning, everyone. I'm going to briefly talk about two of my projects. The first one is my dysarthric speech recognition project. Dysarthria is a neurological disability that affects how we talk. With this impairment, there is nothing wrong with respiration. That is our lungs producing the airflow energy that we use to produce a speech. There is nothing wrong with phonation. That's our vocal tract that transform the airflow energy into voice. But because of this impairment, we lose control over the muscles that are involved with articulation. And as a result, our speech can become like this. No voice. This can happen to any of us at any time. I can go to sleep tonight completely healthy, wake up in the morning with a stroke, and basically suffer from facial muscle paralysis, or I can be to an accident, a bang to the head, here goes my speech. The extent of the muscle paralysis in these individuals in severe cases can be beyond the facial muscles. So it is typical with severe cases that these individuals are also handicapped, which means they cannot use the conventional ways to interact with computing and computer devices. So on one end, we can't understand them, so they can't communicate with us. On the other end, they can't interact with computers. So no digital life, no social life. Speech recognition technologies can be life-changing for these individuals. Unfortunately, the normal speech recognition systems perform very poorly to recognize their speech. So in the past 11 years, I have been building a speech recognition system tailored for these individuals to enable computers to hear them and to basically help them to interact with computers and also use computers to talk on their behalf. However, the impact of this research is beyond the speech recognition. It can help us to unlock new sets of tools and technologies. For example, we will be able in a position to design an automated speech therapy system that uses the AI to basically deliver the speech exercises designed by speech and language pathologists, monitor the patient and interact with the patient to actually help them find their voice. The other project that I would like to talk about today is my Autism Artificial Intelligence project. Few statistics first. This is estimated that there are more than 93,000 autistic individuals are in New Zealand. Around a quarter of them remain undetected by age of 6 and 7, and that age is important. I'll talk about it in the next slide. If we apply the same stats to Maori population, we will have around 15,000 autistic Maori, in which around more than 3,000 of them remain undetected by the age of 6 and 7. So the mean age of diagnosis in New Zealand is around 6 to 7, which is 2 to 3 years after parents, caregivers express concern. What it basically means is the diagnosis procedure in New Zealand takes around 2 to actually 3 years, which is already 3 years later than the optimal age of delivering the support to our tamariki. Among the reasons that this diagnosis is actually delayed is the complexity of this diagnosis procedure. There are two generic sets of algorithms to detect autism. The first one are screening technologies. They are easy to apply, accessible, but inaccurate. And then we have diagnosis technologies that requires to be administered usually by several specialists, and they can become very expensive. So with Autism AI project, I'm designing a multi-AI system to basically deliver the accessibility and ease of access of screening technologies, but push its performance towards diagnosis basically technique. The first AI module has already been implemented and operational since 2018, and I'm mainly using it to collect data to build the other AI systems. So far I have collected data from around 10,000 individuals across the world. Thank you.